Astronomy is one of the oldest sciences. As soon as we could, people have been looking up and exploring the sky, watching the stars and trying to understand what our place is in this vast universe. Even though we see the same stars that have been shining down on civilizations for thousands of years, our understanding of how the universe works has changed dramatically. One of the first models of the solar system was put forward 2,000 years ago by the ancient Greek astronomer Ptolemy. He placed the Earth at the centre of the universe and then had the Moon and the Sun and all the planets that were known at that time orbiting around us. Ptolemy's model was based on observations that he made, countless nights of watching how the planets moved across the sky, sometimes speeding up or slowing down, sometimes even changing direction. We call that retrograde motion. To make his models match the observations, it wasn't enough for the planets to simply orbit the Earth, but by adding epicycles, where the planets move on little circles and then those circles orbit around the Earth, Ptolemy had developed quite an accurate geocentric model of our solar system, one that could correctly predict where the planets would be at a future date, and therefore this model stayed around for about the next 1,500 years. Of course, today we now know that the Earth isn't in a special place in the solar system, and this idea is often attributed to Copernicus. In the 16th century, Copernicus removed the Earth from the centre of the solar system and instead placed the Sun there at the centre so that all the planets orbited around it. But Copernicus wasn't the first to do this. There was an ancient Greek astronomer, Aristarchus, who also put forward the idea of a sun-centred or heliocentric model of the solar system. However, his idea wasn't accepted at the time, and neither was Copernicus 2,000 years later. One of the main issues is that with science we need to have observations and experiments that we can test, and because he still wanted to have the planets orbiting in perfect circles, Copernicus's model wasn't as accurate as Ptolemy's. So there was no incentive to switch from the geocentric to the heliocentric model. Tycho Brahe was one of the last astronomers to observe the movement of the planets before the invention of the telescope. And in his model of the solar system, Earth remains in the centre, and you have the Sun and Moon orbiting around the Earth, but orbiting around the Sun are all the other planets. Brahe had found an interesting way to join the geocentric and the heliocentric models into one. Brahe also made meticulous observations of the planets that ended up being used by his student, Johannes Kepler. And it really is Kepler that we can thank for the model of the solar system that we have today. And the important thing that Kepler did was that he took away that idea that the heavens had to be perfect and that the planetary orbits had to be circular, and he squished those circular orbits, creating ellipses. With the planets following elliptical orbits around the Sun, we finally had a simplified model of the solar system. And using straightforward calculations, it was possible to accurately predict the position of the planets and also explain their movement across the sky. Around the same time that Kepler was coming up with his laws of planetary motions, another famous astronomer, Galileo, became the first to point a telescope up to the heavens. He saw many new and amazing things and made a number of discoveries that helped support Kepler's heliocentric model of the solar system. Of course, it's all well and good for scientists to understand that we live in a sun-centred solar system, but it's also very important to share that knowledge with the public. Many beautiful hand-drawn illustrations exist depicting the different ideas of how our solar system worked. By the 18th century, with the heliocentric model firmly in place, people began to build what we call orreries, which are mechanical clockwork models of our solar system. Because if you can see the planet's motion in action, it really is such a better way of understanding how the solar system works. But the thing with these models is that it was only really the wealthy that could afford them, and it would only be a small group of people being able to look at the orrery at any time. By the 1800s, the magic lantern had become a popular form of entertainment, And they were quite significant, especially in Australia, for communicating the wonders of astronomy. Some lantern slides could even be animated to show the orbits of the planets around the Sun. In fact, those beautiful magic lanterns are really the forerunners of the projection systems that we now use today here in the planetarium. The 20th century was a remarkable time in science, and particularly in astronomy. The launch of Sputnik in 1957 marked the start of the space age, when it became possible for us to start exploring the planets of the solar system, not as tiny dots in the sky, but as actual worlds, each one unique and spectacular and so different to the planet we call home. Our tiny planet orbits one star amongst the billions of stars that make up our Milky Way galaxy, which is just one of the trillions of galaxies that make up the universe. But what's really exciting for me is that all of these advances in technology and the many scientific discoveries built up over thousands of years means that here in the planetarium, we can create realistic views as if we are journeying through space and can better understand and appreciate our place in the universe.